Hello everyone. Here we're going to be talking about how Abdul maximizes his utility subject to a constraint. And when we're thinking about this, we're trying to think about the Nash equilibrium between Abdul and Bridget in our fishing game in chapter 5. So we have the two players, we have Abdul and we have Bridget, and we need to think about how they will achieve their Nash equilibrium in the interaction. So unlike in chapter 1, where we had a 2x2 game, we now have continuous choices of the number of hours that they will spend fishing. And so to do that, we have to think about what they might do to maximize their utility subject to a constraint in order to understand their best response functions. So we're going to first determine how many hours Abdul will fish when Bridget is fishing for some given number of hours. We're going to start with when Bridget doesn't fish at all. So H superscript B, or Bridget's number of hours of fishing, are going to be 0. So then the question is, if H superscript B is equal to 0, how many hours will Abdul choose to fish for? That's what we're going to have to think about. And so we're going to do this thinking about his utility function, thinking about his marginal benefits and marginal costs of the choices that he makes, and we're also going to go back to the marginal rate of substitution being equal to the marginal rate of transformation condition that we established in chapter 3. Okay, so let's look at some of these ideas. The first thing to think about is Abdul's utility function. So what do we say here? We say that Abdul's utility function is dependent on his hours of fishing and YA, his fish that he can consume. Now, YA is positive. So we know that his consumption of fish, the fish that he can consume, that is going to be something that has positive marginal utility. That is something that gives him utility. That's something he wants more of. But then he incurs a cost of fishing, which is minus 1/2 HA squared. So the number of hours that he spends fishing, square that, multiply it by 1/2, and take it away from his consumption of fish. That is his disutility from fishing. So the production function, in terms of how he actually gets the fish to consume in the first place, is equal to some output of fish, x superscript a, as a function of his hours of fishing and Bridget's hours of fishing. And that's equal to the hours he spends fishing multiplied by alpha minus beta times HA plus HB. Okay, so what do we have to do now? We're going to have to think about two different things. We're going to have to think about his marginal costs and his marginal benefits. So his marginal costs is simply what we think of with his total costs. The total costs are 1/2 HA squared. So just taking that cost term out of his utility function, thinking about a term in itself, we take that and we differentiate it with respect to HA. We can see that his marginal costs of fishing are equal to HA. The number of hours he fishes, that's basically just his marginal cost of fishing. Now, the marginal benefit of an extra hour of fishing, what do we have to do to think about that? We're going to take that production function, XA, and we're going to differentiate it with respect to HA. So we've got this whole thing over here, HA multiplied by alpha minus beta HA plus HB. When we differentiate that with respect to HA, what we get is alpha minus 2 beta HA minus beta HB. Now, the thing is that we know when HB is equal to 0, then that third term is also going to be equal to 0. So when Bridget doesn't fish at all, then what we have there for his marginal benefits are alpha minus 2 beta HA. Okay, so those are his marginal benefits of fishing when Bridget doesn't fish. And then we also have his marginal costs of fishing, which are equal to simply HA. Now, what we can see there is that HA appears in both of these functions, both in the marginal benefits and in the marginal costs. So we can draw a graph looking at the number of hours that he will choose to fish, and we can think about the marginal benefits and marginal costs, and we can also think about what his marginal rate of substitution and marginal rate of transformation would be. So let's go in that direction now. So what do we have here? We've got a variety of things that we're going to want to think about. And we're thinking, as I said, about this topic of Abdul maximizing his utility subject to the constraint of his production function when Bridget does not fish. So we've got his production function when Bridget does not fish. That is our green feasible frontier here. The production function gives us the feasible set of how much fish Abdul can get from spending hours fishing along the x-axis here. That's HA. We can see that indicated on the bottom here. Abdul's hours, HA. So when we think about that, we've got his hours over here on the x-axis, and we've got a couple different things that we can look at. So the first thing is that we have three indifference curves for Abdul, U1A, U2A, and U3A. So when we think about this, we now are going to think about three different points: point F, point G, and point H. We want to understand for ourselves these points are associated with him fishing for 6 hours. We can see that because it's associated with this 6 on the x-axis in both cases. And we want to understand whether those are best responses for Abdul when Bridget fishes 0 hours. So what do you think? Are those points best responses or not? Why or why are they not best responses? Take a moment to try and think about that for yourself, and then we'll proceed to understand whether or not they are best responses. Okay, so having taken a moment to pause and try to answer that question yourself, let's unpack it a little bit. So, the first thing that we can see is at point F in the top graph, we've got Abdul's indifference curve intersecting the best response function. We're intercepting his production function, the feasible frontier. So what that means is at that point, the marginal rate of substitution does not equal the marginal rate of transformation. In fact, it's the case that we can see that the two slopes are different, and therefore the willingness to pay is not equal to the opportunity costs. So what we want to think about there is that Abdul could in fact be better off by increasing his hours of work and thereby getting more fish to consume. Okay, so remember, fish to consume is a thing that's beneficial to him. He wants to get more fish to consume, and he wants to achieve a point where the marginal rate of substitution is equal to the marginal rate of transformation. Where does that happen? That's going to happen at point S. We're going to get back to that in a second. But the first thing is we've diagnosed in the top figure that point F is not a best response. Okay. The second thing that we can see is that if we compare points G and H, we can see that at point G, we're on the marginal benefit curve. The marginal benefit curve, if you recall, what do we see for that? What was our equation for it? Marginal benefits were equal to alpha minus 2 beta HA. So remember, this has to be a downward sloping curve. The marginal costs were equal to HA, the number of hours that he spent fishing. Okay, so knowing that with the marginal benefits being equal to one this function and then the marginal cost being equal to HA, what we can see at that point is that the marginal benefits are greater than the marginal costs. So because the marginal benefits are greater than the marginal costs, it would be in Abdul's interests to continue to fish, to spend more time fishing until such a point where his marginal benefits equal his marginal costs. So he should continue choosing to fish, increasing his number of hours until you again reach point S. Point S would be the point at which his marginal benefits equal his marginal costs, and that would be a best response at that point for the given hours that Bridget is fishing. Okay, so to think through that even more, we know that Abdul, again, we're just thinking about him maximizing his utility subject to the constraint of his production function. At point F, the marginal benefits of fishing more were greater than the marginal costs of fishing more, therefore he should continue fishing. Abdul can also earn more utility by fishing more than 6 hours. By increasing the number of hours that he fishes, he will move up to a higher indifference curve and increase the utility that he would receive. So he will maximize his utility by choosing the fishing time such that the MRT is equal to MRS, the marginal rate of transformation equals the marginal rate of substitution, or the opportunity cost of greater fishing time equals the willingness to pay of fishing time for more fish. Okay, so that's what we think he wants to achieve here. Now, that happens at point S. Also at point S, what happens? We know that we are at a point, so just as a reminder in terms of MRT equals MRS, the MRS, what's that defined as? The MRS is the negative of the slope of the indifference curve. So we can think about that coming from our indifference curve here, and we know that we've got the slope of the indifference curve over here at point, reminder, that's point S. So we've got the slope of the indifference curve at point S being equal to the slope of the indifference curve at point S. They are tangent at that point, therefore their slopes are equal. So what we can write there is MRT equals MRS. The negative of the slope of the indifference curve equals the negative of the slope of the feasible frontier. So MRS equals MRT. So when that happens, when your trade-offs are equal to your opportunity costs, you are maximizing your utility subject to a constraint. Similarly, at point S, as we're going to unpack further, marginal benefits are equal to marginal costs. So, what else are we thinking? At point S, we can also see that marginal benefits of fishing an extra hour equal the marginal costs of fishing an extra hour. The marginal costs equal HA. The marginal benefits equal alpha minus 2 beta HA. We can set those two things equal to each other and isolate HA. So when we isolate HA, what does that mean? It means that our number of hours are going to be equal to alpha divided by 1 plus 2 beta. Now, because beta is equal to 1/2 and alpha is equal to 30, that means that HA equals 15. That's exactly the number that we have here. By setting marginal benefits equal to marginal costs, we find that the utility maximizing number of hours is 15 hours of fishing when Bridget doesn't fish at all. Now, as you will see later in the book, what happens is we will vary the number of hours that Bridget fishes, and we will see that as Bridget fishes more and Abdul sets his marginal benefits equal to his marginal costs, the number of hours that Abdul will fish when he maximizes utility will decrease. This also corresponds to the marginal rate of substitution being equal to the marginal rate of transformation, or the two best response functions intersecting at the Nash equilibrium, as we will see later.